Alright, welcome back for part 2 of torture, also known as equivalent fractions. In this video we're going to talk about the vocabulary term that I kind of mentioned in the last video, fractional forms of 1. What I mean by fractional forms of 1 is you are starting with 1 and you're turning 1 whole into a fraction. So what I can do with 1 whole is just like in my last video where I used this. You can take 1 whole and you can cut it into 2 pieces, and then you end up with 2 pieces out of 2 total. 2 over 2 is equivalent to 1. If I were to take that same 1 whole and cut it into 3 pieces, I would have 3 pieces out of 3 total. Continuing the pattern, I could have 4 out of 4, 5 out of 5, and so on. 6 out of 7, 8 out of 8, 9 out of 9. And any fraction that I want. What's important is that I have same number on top as the number on the bottom. So same number, same number. Have the exact same thing on top, exact same thing on bottom, and that is a fractional form of 1. Alright, what this does for us. When we are asked to find an equivalent fraction to say something that's kind of weird, like 5/8. You can use any of these fractional forms of 1, and as we know, multiplying by 1 doesn't change the value of 5/8. If I multiply by 1 whole, it doesn't change the appearance either. But if I want to find an equivalent fraction to 5/8, I would start with 5/8 and I would multiply it by, pick any of these that you feel like. I'm going to choose the easiest one, 2 over 2. And then when I multiply across, I get 5 times 2 is 10, and 8 times 2 is 16. So I end up with the equivalent fraction, 10/16. These two equal each other, and I found them by using the fractional form of 1, 2 over 2. What I'm allowed to do at this point is, now I can use this equivalent form of 5/8, or I can go back to 5/8, and I can use either of them to find an unlimited number of equivalent fractions to 5/8. I always like starting back with the original so that way I don't miss any. Plus, you may notice a pattern once I do this one. So take 5/8 again. If I need to find 2 or 3 equivalent fractions, let's just pick the next fractional form of 1. We did 2 over 2. The next one would be 3 over 3. Let's see where that gets us. 5 times 3 is 15. 8 times 3 is 24. So again, we have another equivalent fraction of 5/8. So let me start, scooch down here, and I can start running a list. 5/8 is the same as the next one that we found would have been 10 over 16, which is also equivalent to 15 over 24. Let's find one more, and hopefully you just start noticing a pattern down here. If not, I'm going to point that out in the last 30 seconds of the video. Alright, so again, we will compartmentalize everything so that way it's not too confusing. 5/8, we'll come over here, multiply by our next fractional form of 1, 4/4. 5 times 4 is 20, 8 times 4 is 32, so our next equivalent form of, our next equivalent fraction for 5/8 is 20/32. All of these are equivalent forms of 5/8. We found them by using different fractional forms of 1, 2/2, 3/3, 4/4, 5/5 we didn't find, but if you've noticed the pattern, finding 5/5 won't be that challenging. As you notice on the top, you are counting by 5s. On the bottom, you are counting by 8s. So if I were to continue the pattern, 5, 10, 15, 20, I know my 5s pretty well. The next one is 25. The next one is 30. The next one is 35. I also know my 8s pretty well. 8, 16, 24, 32, 40, 48, 56. All of these are equivalent fractions to that guy right there, 5/8. And we can find them using multiplication, or if you prefer making a huge list, you can use addition as well, as long as you add the top to itself and the bottom to itself. The reason it works is because this is the same as multiplying by 2/2. This one's the same as multiplying by 3/3. This is like finding the 4th multiple of both. This one's like finding the 5th multiple of both, the 6th multiple of both, and the 7th multiple of both. And what I mean by the 7th multiple, 5 times 7 is 35. 8 times 7 is 56. Okay, so always look for patterns in math. You can make a huge list like this using addition, or if you prefer finding a very specific one, that's when multiplication comes in handy. Thanks for watching my video. Hopefully you learned something.